to others. And the talk is SIEM, Escape and Evade. Over to you.
Thank you very much. Can you guys hear me now? Yeah. Okay, perfect. All right. Well, first of all, thank you for coming along. I know that we're competing with the bar and this is the last session, so we appreciate everyone making the effort to come along today. So the topic for today, or the object, should I say, of today is talking about SIEM tools, but what we want to be focusing on is what you could do to potentially evade the detections in a SIEM tool. So we're going to be talking about some of the shortcomings in SIEM tools when it comes to threat detection. But let me maybe kind of state that three of us up here, we still think that the SIEM is a very, very useful tool, right? But as long as it is constrained to what we call very, very tightly defined use cases. And what this means is that you, having a tightly defined use case means that you and your company understand what the SIEM tool does and doesn't do, and also crucially can help you control the costs. Because if you've ever dealt with that side of a SIEM, the cost is a very, very significant factor. So specifically, we're going to be talking about SIEM deployment profiles from an evasion perspective. I think it's important to understand the likely deployment and what that looks like. Things like agent interruption, disrupting the log source, and then also rule bypass. Finally, we'll hand over to Guy here for some closing thoughts. So I think some introductions might be in order, first of all. My name is Daniel. I'm the pre-sales director at Vectra AI. Before this, I worked at Logarithm. If you've ever dealt with SIEM tools, you might have heard of Logarithm. I was there for about 4 years. Before that, I was at McAfee, where I was the SIEM specialist for pre-sales, the enterprise security manager, if you've ever heard of that. And then actually before that, I worked for an Australian-based SIEM vendor called Huntsman, which is still around. So with me today, I have Mr.
Niall Laherty, that's my name. I didn't get the memo about the stupid photographs, so mine's quite professional on the slide. I work in professional services, been doing it for about 12, 13 years now, specifically in MDR and incident response. Prior to where I currently work, I was very much focused on endpoint forensics, and I'm also joined by...
Hello, my name's Guy Kramer. My background is 17 years as a practitioner and consultant in security operations, building and improving SOCs for government and commercial entities around the world for various companies such as Capgemini, Rolls-Royce, and then ArcSight, don't shoot me, until a couple of months ago when I decided to go on my own and set up my own advisory company to help customers. Basically SecOps veteran and people process technology, which is where I'm going to sort of fit into this as well. So first of all, what we're going to talk about is a real life example. Most of you will be aware of what happened in 2017 with CloudHopper, so APT10, or the PLA, where they were actively targeting managed service providers to be able to get through to some of their end customers. And they were using this as a mechanism to obviously get hold of intellectual property, to be able to disrupt customer operations. Now, at the time, I was working for a company who was actually impacted by the breach of one of the larger MSSPs. So what the attackers were doing were compromising the MSSP, getting on a jump box, and then from a jump box into a client's environment. And then I was one of the ones using the SIM tools within that customer to be able to identify and track the activity. And then we actually flagged it up to the MSSP at the time, which was a really interesting conversation. At that point in time, there hadn't really been much done in that area. What we are seeing with what's happening at the moment, I was at Cyber Threat 24 on Monday, Tuesday this week with the NCSC and SANS. And, Record the Future, they were giving a talk around how actually China is the largest adversarial threat that we've got at the moment, even more than Russia. Reason being because within China, they've had half of the GDP go away. They've had a number of other changing factors which affects the amount of power that they have. The reason why they're so keen now to be able to target and focus on potentially supply chain and MSSPs still is they're trying to build up their economic value by our investment in the green energy. So previously they'd taken or targeted Germany, where there was a lot of investment in solar power, and that's why all of a sudden you then started seeing on AliExpress a load of solar power inverters and everything else. Well, now we're probably going to see China focusing on any sort of green energy, and obviously with the investments by the government, we're seeing plenty going into green energy, as well as the space race, which actually China publicly released that they're going to start a space program this year. So there's only going to be even more focus on attacks, similar to the original Cloud Hopper, more and more so. So this is where, although these MSSPs are providing services, it still needs to be something that individual organisations need to be able to account for that risk in case that MSSP is compromised.
So, you know, in terms of what it is that they were trying to do, as I say, it's mainly about stealing intellectual property so that they can take the patents or whatever and designs and being able to recreate those. But also any sort of sensitive data that could be of interest to them. And then I shall hand over to my colleague.
Cool. Thank you very much, guys. So I guess maybe let's start. So who in the room feels like that they are very familiar with SIEM tools? Put your hands up. Okay, so there's a couple. For the benefit of everyone in the room, let's talk about some concepts first. Like, let's tie this back to SIEM or bring this back to SIEM. What is a SIEM, first of all? Again, bear with me. Security Information Event Manager. It's generally where you shovel all your logs. Okay, traditionally, it's been like one of the core threat detection tools for the SOC for many, many decades. And I think the idea of centralizing your logs for security purposes has always been a good one. Now, SIEM vendors love that because log volumes never go down. They only ever go up, which means that the licensing cost goes up because SIEMs are almost always licensed based on the amount of logs that you shovel in there. SIEM vendors will also purport to say that they do other use cases like threat detection, which we're going to talk about, and also threat management, which they often do generally fairly well as well. Okay, so that's what a SIEM does. The three main uses for a SIEM: log management, threat detection, and threat management. And when it comes to SIEM deployments, there's many different types. I think if we break this down and look at this, like I said, from an evasion perspective, I think it's useful to understand what the likely deployment looks like, because that gives us an understanding of the likely configuration of the SIEM. Okay, so you've obviously got smaller deployments, and this is probably pretty obvious, but I'll go through it anyway. Smaller deployments, and we've seen many of those, right? And, you know, we're talking about situations where you might have very, very basic log sources, and that could be coupled with very, very basic out-of-the-box correlation rules. And in a lot of instances, the alerts that are raised by the SIEM are probably not all picked up as well. Okay, so that would be a smaller deployment. Now, obviously, converse to that, you've got larger deployments, things like banks, and they would have a dedicated SIEM engineering team. So these are the SIEMs that, you know, quite naturally would be much more highly tuned, custom correlation rules, custom detections, and they would be managing their detections much more closely than a smaller deployment. The other type of deployment is like a situation where you might have a large organization that uses an outsourced, potentially tier one SOC. So this is common as well, right? And, you know, not all SOC providers, not all tier one outsourced providers are similar, but a lot of them, what they would do is they would take the same set of correlation rules or the same set of alerts, which we're going to talk about in a bit, and they would overlay them across all their customer base. And that's how they scale. That's what they would generally do. But I think it's important to understand, first of all, if you're in that situation, understand what the logic is behind those rules and whether or not they are fit to reducing the risk of your company. But from an evasion perspective, it could be useful to understand that because it's highly likely that they could be using some kind of publicly available or out-of-the-box correlation rules, and a lot of them are actually published online. So let's dive into maybe just touch on some deployment profiles.
Yeah, so I suppose there's three different types of kind of customer that we see. We see the small, the medium, and the large. Of course, you do see different customers, different stages of the life cycle. But in general, when you work with a small customer, they have a very specific set of problems versus what a large customer would have. On the screen here, you can kind of see a breakdown of like the common use cases a customer would have, starting off with just compliance, moving up towards like the SOC usage, all the way through to hunting for the larger kind of scale deployments. Each one of those then will have their own unique challenges, as I said. We've worked with small organizations who have a very small environment, very small footprint. They can get logs quite easily. It's typically cheaper to deploy, easier to deploy. It's based usually in SaaS, and they can get that data and we can see their environment pretty easily. The problem with them generally is a process element where they have not operating 24/7. They haven't got the people, the training, issues like that inside their environment. If you move up the scale, we've worked also with very, very large organizations. I can think of one specific example from last year where an organization, around 25,000 people, was very well deployed, good visibility, using a SIEM tool, and they had a fairly major breach inside one of their environments. This organization that we work with, we feed into their SIEM as like one kind of source of information for them. But in this specific instance, they found that there was no visibility from the SIEM platform itself. When it came down to it, it was very much about a data issue, right? Because when it comes to these very large deployments, getting the right data is extremely difficult for those environments. So again, you got to think about the kind of environment that you're working in. If you are working in the SIEM side, if you're a red teamer, think about what you're targeting and those specific use cases and issues they might come across, because they're going to be different for each deployment.
Thank you, Niall. So let's pivot now and let's talk a bit more about SIEM tools, specifically looking at the architecture. So this is just an example. Microsoft Sentinel, very, very common SIEM. I think the main difference between cloud SIEMs and previous on-premise SIEMs like Logarithm and ArcSight is that the log processing pipeline. See, there's a lot of components that go into a SIEM, right? In a cloud SIEM, it's a bit more streamlined in the sense that you've usually got agents on this side. So if you've got servers on premise, they would typically have agents installed that collect the logs, and then they send that, in this case, via Defender for Cloud, but to a log analytics workspace if you're using Sentinel, and then Sentinel would sit alongside that. Okay, other cloud SIEMs would have very similar architectures. So from an evasion perspective, if you're looking to evade specifically the detections in a SIEM, there's some very obvious things that are highlighted here. One of them being the agents, and the other one being that connection between the agent and the actual SIEM, right? So, talking a bit more about log sources themselves, in order for a SIEM to work, you need to be able to get logs into it. As I said, from the perspective of what we're talking about here, an agent is something that sits on the server that collects the local host logs. And, sorry, there's a bit of echo there. But there are other ways. So for Sentinel, what you need is this thing called the AMA, the Azure Monitor Agent. And this is a fairly new thing. Microsoft have deprecated the MMA, which is the Microsoft Monitoring Agent. And you need to have the server joined to Azure Arc. But then what that does is that collects the host logs on the Windows server and then sends them into your log analytics workspace. There are other log collection mechanisms as well. So syslog API is very common for cloud sources, but you can also have flat file. Now, when it comes to SIEM processing, any kind of issue with the collectors or the log processing pipeline leads to misdetections. And, in our experience, we've seen that many times, haven't we? Right, where alarms don't trigger because the log source stopped logging, the agent went offline, or any manner of things happened in that time. Okay, so, to talk about evasion, right, let's talk more about log source disruption. As I said, misdetections due to processing issues is a common issue with SIEM. So if we were deliberately looking to do this, some very, very basic strategies could be to disable the SIEM agent. So go after the agent, right? So it might look something like this. Disable the SIEM agent. If this is a Windows machine, disable the SIEM agent, perform some kind of action, clear the Windows event log, and then restart the agent. Very often there's some kind of heartbeat mechanism, right, built into it where it would alert if an agent goes offline. Very often there is some kind of alarm, which often isn't turned on in our experience, where if a log source goes offline, an alarm should be raised, but because of the noise level of that, I think that we often find that is not often enabled, right? Another way is to suspend the Windows event log, perform the action, and then unsuspend the Windows event log. So just a very quick overview, shall we say, demo of what this would look like, here what we're doing is creating a local user in order to generate an event. And what that does is that creates an event in the good old Windows event viewer, still knocking around. EVID 4720. This machine is joined to Sentinel. So of course we, to Microsoft's credit, the log appears there almost straight away in all the tests that I've ever done. So what we're doing is we generate the log, and now we're looking, and the log appears in Sentinel, and now we're looking at disrupting the agent. There wasn't actually a clear way, a process that I could find anyway. You guys might know something different, but actually killing those kind of funny processes seemed to stop the AMA. And then, of course, if we go ahead and create the user, we still get the EVID 4720, as you'll see. We go back to the Windows event log. Let's filter, refresh. But then what we do now, so we get 4720 again, but then you click clear log, and that clears the log. You'll notice that there's one left there, which you'll see in a second, right? Of course, we don't get 4720 because the event log is cleared, right? But you do get this other log, which you'll see, 1100. It's called Windows event log cleared. So agent is restarted. Within the heartbeat period, we get no 4720, but we do get in a second, yeah, there we go, 1100, which is Windows event log cleared. I think that's a pretty good scenario to set up for the SIEM on 1100. You shouldn't often get that event ID in a production environment, but the presence of it would indicate something malicious going on. Okay, but what if we wanted to avoid that being written completely? So it appears that there are ways, shall we say, this tool is a couple of years old now. What it does, it suspends threads that are associated with the Windows event log service. So the Windows event log service is still running, but if we run this tool, it purportedly suspends the threads so logs don't get written. Remember, what we're trying to do is evade detection by the SIEM by disrupting the actual agent itself, but we're doing it in a way that avoids the heartbeat alerting. Okay, so what I just showed you, like a red team or someone could create a local user and then completely cover their tracks, right? And if the events don't make it to the SIEM, the usefulness of the SIEM in a subsequent incident response scenario is very, very limited because the logs aren't there, right? So here's another quick video just showing that tool in action. We create a local user, just add the username and password. We get 4720. 4720 again. I'll just speed that up a bit. We see that login Sentinel. But then if we run our Phantom tool, you can see that the Windows event log is still running. We create a local user again, and then nothing's written to the event log, not even 1100. So in this way, you could almost completely hide your tracks on a Windows machine by suspending the Windows event log. And like I said, that tool seemed to be fairly available. It was a couple of years old, but it still worked. So let's move on and just talk about cloud. Like I said earlier, API-based and cloud-based log sources are very common in the SIEM these days. Obviously, a lot of people, especially here in the UK, are using cloud services. So I think cloud-based log sources are very important to have in the SIEM. But it's also important to understand that the cloud logs can be disrupted as well. Right. So a quick test. We've actually got a tool that we can run. This one's called Halberd. The link is down below. What this is a cloud security testing tool, and it can perform techniques in a cloud environment that would potentially be performed by a red team or even a threat actor. So in this case, what we can do is suspend the logging or set a policy to disable resource logging in Azure. And the idea of this being that you run something like this Halberd tool, you perform these techniques like suspending logging on an Azure resource, but you're doing it in a controlled way. And what you're doing is you're trying to figure out if you're going to get if any alerts are raised. Is the SOC notified of this? If not, then you've identified a gap, because actually disabling cloud logging, I think, is going to be quite a big thing, from here on in. So let's move on. I'm going to pivot a little bit, just touch on parsing. If you're familiar with SIEMs, you'll know what I'm talking about. Parsing is very, very common. It's what underpins a lot of what goes on in the SIEM. And what I'm talking about when we're talking about parsing is applying a regular expression to a string, like a log line. And what the regular expression does, it pulls out the interesting bits of information. And those bits of information is usually what underpins the reports, the dashboards, and also the rules as well. Okay, so if the parsing is not set up correctly, then oftentimes things just aren't going to work and your detection may not fire. So that's one of the first things to check. I'd say the common log sources are very often well supported by SIEMs these days, but when you get to less common log sources and often custom log sources as well, the parsing coverage in our experience is just not that great, right? It can be complex and expensive to maintain parsing rules, but it's important to note that, it's a problem for SIEM deployments, I think, and probably will continue to be, right? So, just be wary of parsing issues as they relate to rules, which I think we'll move to right now. So let's pivot and talk about SIEM rules in a bit more detail.
Cool. So, we talked a little about the data and getting the data into the SIEM and something the actual agent itself, but one of the key parts, or the most important part once you have the data inside there, is getting the rules to actually trigger on the behaviors you want to trigger on. The question is, where do these rules come from? Well, in a lot of places that we work with, generally the rules are coming from the SIEM vendor themselves, and these rules are typically not very robust, right? They're usually pretty basic. So what ends up happening with those more mature customers is they kind of figure this out over time. We're doing red teams with different organizations. They have to kind of augment their capabilities with new rules. So they either go to third parties or they have the teams internally start creating those rules. When I was doing the research for this, I was actually going directly to Chronicle's GitHub page. Splunk has a fantastic page you can go onto. It gives information about actual rules themselves. But today, someone pointed out a brand new website to me. It's called Control Compass. It's actually fantastic. If you do want to figure out about the coverage for your specific MITRE techniques or what your vendor is providing to you, check this website out and you can see exactly what's covered inside your environment. So, it's a bit easier. Okay, so with this in mind, let's take a look at the actual rule itself. So in this example, I would just look like Chronicle. Chronicle uses Yarrow rules. And on the screen here, you see an example of a Yarrow rule. This one was directly pulled from Chronicle's own GitHub page. Now, you might notice it's looking for calc.exe, which is not typically a very malicious process. However, this is actually a sample that they give you because a lot of red teams do use this as part of the testing frameworks that they have. At the very top, you'll have kind of the details about it. So if you're new to rules, you can kind of see what the MITRE technique it is that's trying to pick up. You can see some links to what exactly information they might have used to generate the rule. And then below this, you can see exactly what the rule is. In this case, it's a regular expression, just looking for calc.exe from two different sources, either from the event ID of 4688 or type 1, which is under the event ID. You also have, it's looking for basically not inside of the usual location for calc.exe to execute from. So again, a very simple example, but what was interesting from looking through all these rules is that in most SIEM vendors, over 40% were using these kind of process-based detections. I was quite surprised myself about this. I thought it'd be kind of more robust or more kind of interesting rules, but a lot of them are just based off this specific event ID, over 40% as I said. And again, just highlighting here what the part is that really matters if you are trying to figure out the rule itself. So you're probably thinking, there must be kind of more robust rules, right? Well, again, from the research I've been doing, not really, right? You might find rules where it's more generic. Like, for example, if you're trying to dump credentials from a domain controller, they might just put all the different processes together into one single rule and call that, dumping or potential data dumping from the domain controller. But again, in general, you're not going to find very robust rules. You also find rules that have command line arguments, or they are part of the rule itself. If you do find those ones, they're extremely easy to evade, which I'll just talk about now in a second. So once you've kind of identified a SIEM that's being used inside your target environment, or if you're on the blue team side trying to figure out your weaknesses, you then have to figure out how would you actually go and evade that. Well, there's a multitude of different ways you can do it. The most common way you do see is actually just moving the binary from its usual path, right? This can have varying degrees of success. It might have dependencies where you can't just move it easily, or you might be able to relocate it and then run it if you can. The command line exe is pretty easy to do that with. From there, you could also try to indirectly invoke it, and by that I mean like not running it directly from its process location, and maybe run it in memory, which will not actually have a log file created in the first place. With PowerShell, you can run Parsploit, you can run reflect PE injection. This is a fairly common one for red teams, and it's all the time, no log file created with that. If there is a command line, this is, again, very easy to obfuscate because you can actually go in and modify the command line arguments, again, bypassing the rules logic. Fairly straightforward. I'm going to show you some examples of that in a second. The last part of this is you could actually disable the logging itself, as you already talked about. This one I'll talk about in a second in a slide or two, but again, it's going to be some challenges with doing that itself. When I was testing this, I went through some examples of testing it. I was using Splunk for the example. Splunk is just fairly easy to spin up as a lab environment, all self-contained in the same system, and it's free to do with it as well. I also leveraged just some information for Chronicle on their website. When it comes to bypassing the command line arguments, I found some fantastic research where this exact problem has been identified by multiple different vendors out there, as well as some researchers. There's other good talks about this, but I couldn't really summarize it better than I saw this specific slide, as you can see here. With this, you have the evasion types, you have insertion, substitution, omission, reordering, and recording. So the idea here is that you look at the exact logic, as I've shown you, in the rule itself, to figure out exactly what it is that it's trying to look for in the command line, and then you figure out what can actually be executed. In most cases in a command line, you could either reorder the way in which you're executing the binary, or you could put quotation marks, for example, in a command line. All these very simple tricks will all the time bypass SIEM rules. So you might be thinking, okay, well, I have rules in place in my SIEM to identify when there is specific logs that have been changed or cleared on the actual process itself or on the endpoint. That is true. Most SIEMs I've looked at have these rules in place, but generally they're either informational or they're very low priority, not very high priority. So you can use that to your advantage, right? One of the things that you could do is you could run tools like WEVT-util that can actually stop the processing of a specific event or an event going back or being created. And again, in my example for Splunk, there was a rule for this, but the nice thing about this was it was a command line argument, just put quotation marks around it, and again, you can bypass that pretty easily. I know there's red teamers in this room, and I know you guys have done this. I've seen this multiple times being used and easily getting passed. So again, these are not complicated rules to get passed. They're very, very simple, the default ones. What I also find interesting, and I think we need to keep in mind here, is that all the research I was doing around this and looking at the rules, they're all the rules I could see on the public pages, right? Either on GitHub or on Splunk's own page. For Chronicle, and Chronicle's interesting to me because it's a fairly new one and it's getting traction in the field. We see a lot of customers deploying it. There was one specific glaring problem. There was practically no rules around PowerShell, which kind of surprised me. So it got me thinking, there's two things that could be happening here. One is either they are using another set of rules that we don't see publicly. I'd say for Chronicle, that's probably very likely, right? A lot of vendors out there will be showing you the default set, they're free to use, but probably charging their customers for a second set of rules. The second part of this is they're probably relying on a EDR agent to give them the details back to the SIEM itself, right? And that's kind of one of the key points here is that the default rules and default logging that you can use for the SIEM might not be sufficient. You need to have that other source of data coming into your SIEM to probably get good visibility into things like PowerShell. The last point I want to make here is around the PowerShell. So PowerShell, I just love it because it's used by most adversaries, and they will typically use it for many different stages of the attack. But if you look in Splunk, which has been around a lot longer than Chronicle, and you look at the actual rule set, there's about 152 at the time of when I was doing this. And one of the key things here was the data sources, right? If you actually break down where the data is coming from, one of the key parts coming from is event block logging in PowerShell. Now, this is a fantastic log if you have enabled on your endpoints. That's great, you got really good visibility. But again, in our experience, most customers don't actually enable this because of the cost involved in logging it. And obviously, it's going to take a lot of data for them. So that's 102, or 103 was it? 103 rules in total, already gone if you don't do script block logging. The second part you might notice there is they're relying on CrowdStrike as well. So as I mentioned, the EDR becomes a really important part to get visibility into things like PowerShell on the SIEM side.
Yeah, I was going to say there, actually, it's probably worth calling out here that most of the deployments that we've seen actually don't have any kind of command line logging in the SIEM, right? So sysmon can be a very valuable log source in the SIEM, as with PowerShell script block logging, but there's a reason why people don't do it, and that is because it's very costly, especially if you've got thousands of servers, and also you've got the EDR to do that as well, right? But I actually have seen deployments where there is process creation logs. So here's a bit of advice. If you're familiar with the Windows audit policy, there is a thing in there that is audit process creation, success and failure, right? That would create EVID 4688 every single time a process is created. I have seen production environments, large ones as well, where that was intermittently enabled across the server estate. And actually, there is another setting with 4688 as well, and that is include the command line. So without the command line, it's actually, in my opinion, it's useless. Like, for instance, all you would see is cmd.exe in the log. If you include the command line, you get cmd.exe plus the actual, the arguments. So, like malware would invoke cmd.exe. It's very easy to tell from the command line if it's suspicious or not, right? So actually, I would say to you, if you've got 4688 enabled, check that you've got command line, and check if you've got any rules there set up and if you actually need it, because I think if you've got it enabled, you could actually reduce your log ingest quite significantly. In fact, I think you could reduce your log ingest to your SIEM quite significantly by just doing a review of your overall Windows audit policy. So that's, if there's one thing you're going to do, like after this, I'd say review your Windows audit policy, because in my experience, Windows event logs is like not the most, but it's one of the second or third highest log volume sources in a SIEM, right? The first is often firewall logs. And the other thing I'd say, while I'm on that note, actually, the other thing I'd say about firewall logs, do you actually need them in your SIEM? If you've got them in your SIEM, do you actually need them in there? That would be my question to you. What are the use cases you've got for firewall logs? Most of the time, it's just single bad IP address match, which actually is not that useful, because oftentimes you can do that in the firewall anyway. Firewall threat events are useful to put in the SIEM, but actual firewall logs tend to take up quite a lot of the volume, and you pay quite a lot of money for them. So what I would say is, question, do you need them in the SIEM? If you need to retain them for compliance purposes, you can often store them in FortiManager or Panorama, depending on the firewall that you've got. Right, so have a think about that. Come and speak to us afterwards if you want to know more about that particular point. But back to the talk here, right? So so now that we know about SIEM rules, right? So we know that very often, process command line is not logged in the SIEM, but most of the out-of-the-box rules are related to process command line, right? So make sure that you're aware of that when you're assessing your detection coverage. But let's talk more about the rules that are in and working and you've got logs for, and that's bypass. Right, bypassing those rules if you're looking to evade them. Now, the thing with SIEM detection rules is that they're very often very static. So most of them, if you this is why I said before, you want to lift the lid on the rules that you've got enabled or the rules that are provided to you, because very often they're just some kind of threshold based, which is common, okay? And it can be very effective in some cases, but if you wanted to evade them, then you just fly under that threshold, okay? So some other thoughts on rules in general. From what we've seen, most of the SIEM deployments have got several hundred rules enabled, and actually the customer doesn't always know what they do. They might have been enabled a couple of years ago. They're not commented, no one tests them, that kind of thing. So, reviewing your SIEM correlation rules is always a good activity to do, because that aligns with the use cases that I mentioned earlier. But also reviewing the correlation rules understands where you might have shortcomings with regards to thresholds, right? So overall, for the SIEMs that we've seen anyway, bar a few that are very, very well maintained by SIEM engineering teams, there is a minimal detection coverage and easy to bypass kind of techniques. Let me give you an example, right? So I think this is a good example because it's a very, very basic attack, but it seems to be very, very effective, right? In fact, Microsoft was victim to this earlier this year, and that is password spray in Entra ID, right? So obviously, I guess most of you does anyone not use Entra ID for their users? right? There might be some knocking around. Yeah, there's a few. We spoke to a few earlier, like Google Workspace and stuff like that. But by and large, I'd say the majority of clients that we work with use Enter ID, right? And that means that, you can log in from anywhere, right? And this, what we're looking at here on that side is the correlation rule, or the Sentinel analytic rule from the Sentinel GitHub repo for detecting password spray in Enter ID. And it's very, very long, right? But you can see from the very start what the thresholds are. It's quite simplistic, I guess. What it's looking for is 5 failed logins to Enter ID over the course of 20 minutes over the past 1 day from the same IP address. Okay, so what a password spray is when you try the same password across multiple different accounts. And the reason you do that is so you don't lock out the account. Because if you type your password in wrong too many times, the account gets locked out. So you don't want the account to be locked out, so you try the same password. Obviously you don't know what the password is going to be, but you're relying on the users, one of the users having some kind of common password. But if you've got 10,000 users, for instance, there is a pretty good chance that at least 1 or 2 of them could be using some pretty basic common password, right? So that's where password spraying attack could be leveraged. And also, like I said, knowing the deployment profile of the SIEM, which is what we talked about before, would give us an understanding of the likelihood that this rule would be tuned. Okay, so just doing some pretty basic testing in Enter ID. Again, back to this Halberd tool. Very useful, by the way. Right, check it out. You can run password spraying attack in Enter ID. We've got some test users, by the way. So obviously you want to be doing this in a controlled manner, but running password spraying attack against 200 odd Enter ID users using a wait of 3 seconds, it tries 3 seconds, tries the next account, tries the next account. That would clearly trigger the password spraying analytic in Sentinel because we are over the thresholds. But something as basic as setting our tool, Halberd, to wait 300 seconds in between attempts means that we're trying we're trying 4 passwords every 20 minutes, right? And that flies under the threshold, and subsequently the Sentinel analytic rule obviously does not trigger. Okay, so password spraying, I think, is a good example of correlation rule, logic subversion, and I think, interestingly enough, Microsoft do provide password spraying detections, if you're familiar, in Enter ID identity protection, right? But those users were P2 enabled. Maybe it was just the way I was doing it. It didn't trigger, right? That time anyway. I have seen it trigger before, but again, lifting the lid a little bit on the Microsoft Enter ID identity protection password spray detection, right? That says to me that it's fairly basic, because what I think they look for is they look at the password complexity, first of all, and I think they trigger password spraying on that. And then also, they look at the source IP address, and if it's been involved in multiple failed logins. So I guess what I'm saying is there's not a lot, in my opinion, from what I've seen anyway, from what we've seen in the testing we've done, there doesn't seem to be a lot of password spraying protection in Enter ID. So you're down to the correlation rule in Sentinel, which if you're using the default one, which looks really long, and it's very tempting just to take that and import it and say you got coverage for password spraying, it's very easy to subvert the logic by just, running 4 passwords every 20 minutes. Okay. So, I think what the key point here is that, a multi-layered detection approach, I think, is key because, yes, there are other controls in Enter ID, for instance. If a password spray is successful, obviously you've got MFA and you've got conditional access, right? And I think it's important to understand what controls you've got, because if you don't have MFA, right, obviously, that's a big risk, right? But what controls have you got in place to cover you if one of them were to fail? I think with that, let's pivot back to Guy. You want to just give some final kind of thoughts on advice and mitigations on everything we talked about, and maybe you can just open up to questions.
Thanks, Sam. Thank you. So, yeah, we've heard from Dan and Niall there about a couple of different, or quite a few different techniques that can be used. Now, just to reiterate that we're not saying SIEM isn't useful anymore. I think it is a very useful tool, but it needs to be used in the correct manner and needs to be treated with respect as well. Now, what is it that you can do to try and mitigate some of these risks? So there's three areas really that I would suggest that you focus on. So first one is specifically around threat modelling. So any system that you have in an enterprise environment, or to be honest, a small business as well, realistically you should be using some threat modelling techniques. Whether you're using something that's well known, like Stride, etc., or whatever, although some of those can be sort of a bit more daunting and overwhelming in terms of the amount of effort that you have to put in it, whether you've got something that's more bespoke within an organisation of how you model that risk, or whether it's something more lightweight like Pasta. But effectively, you should be working through, you're the security experts, right? What's it going to look to the rest of the organisation if people in your company know that actually your SIEM tool, your primary security tool, is being circumvented, right? They're going to lose trust in the detections and the capabilities that you're providing to the customer or to the company. So, thinking about, we were talking before about agents. Are attackers able to maybe increase the log verbosity of the logs community? So we mentioned before about firewall logs, that they can be very chatty, or DNS. Maybe, for example, they increase the level of verbosity that's logging on those devices, and actually it makes you hit the threshold for the licensing for your SIEM tool. Some SIEM vendors will still log it, some will say cut off and we won't let you have any more logs come in. From a licensing perspective, but actually from a hardware and performance perspective, maybe it can't handle the additional throughput, which means you would lose your visibility. Through to, if it was a cloud environment, potentially, if you're having additional logs coming into Sentinel, for example, yes, it would accept all the logs in, and you're going to pay a lot of money as long as you've got enough to pay for it. So do you have the additional controls in place to be able to circumvent that? And what detection mechanisms have you got that can adequately mitigate that? So that's where we move on to use case definition. The people who were with me this morning in the workshop are probably sick of me talking about this, but threat modelling should feed into the use cases that you're building. Whether it's a hybrid of a bottom-up approach, so for the logs that you've already got going into SIEM, what are the maximum valuable alerts that you can get out of it, but also actually a top-down approach, so almost a hybrid of when you're speaking to the organisation and looking at the risk register, what are the top risks that you're trying to mitigate against, and are you actually providing sufficient mitigation against them? So there was a financial institution that I was working with who had a large DevOps team. They were constantly pushing out updates to a service platform or SaaS-based platform that they were delivering. However, there was no communication between the DevOps team and the SecOps team. So although DevOps were fine to push out their new release, with still containing vulnerabilities in it that were potentially vulnerabilities that a specific threat actor who was already targeting them was able to utilise, they still did that. But actually we managed to work together and get the DevOps teams and the SecOps teams to do some threat modelling in future. And now it's a lot better because they can actually provide some at least detective capabilities to resolve that. And then finally moving on to continuous improvement. So architectures are always changing within a customer's environment. It becomes kind of organic, as well as techniques, obviously, for attackers. And it's important that we update the SIEM logic, etc., to be able to cope with that, as well as vendors who are feeding in logs or, for the logs to be parsed with new event IDs and new things that you could be using within SIEM. So continuous improvement is an important part of that as well. So in essence, believe that we should still be using SIEM. It's just that we need to, as we would put best practice on to other people who aren't in security, that we need to be doing it ourselves to better protect ourselves, and just to be aware of it. And for the organisations who do outsource some of their risk effectively by using a managed service provider, just some of the things that you should be thinking of in terms of the contract that you have in place with that external provider. That's all I wanted, or I had to cover on this piece. So what we're going to do is move on to if there's any questions that anybody has. Yes. Oh, sorry. I didn't see you were saying no in the background. Right.
We're getting these ones.
Right. So the bar. We'll meet you in the bar and we'll talk about it there.
All right.
Thank you very much, everybody.